QPatch is an automated patch clamp system for ion channel screening with either 16 or 48 recording channels. This animation shows the 48-channel QPatch HT. Following QPatch setup, a simple click on the touch screen starts the experiment. To start, the robotic gripper arm picks up the compound plate for barcode scanning. The plate contents are confirmed and recorded to the database for quality assurance. The 48-channel Q-plate electrode array is then picked up, scanned, and placed on the recording area. The intracellular solution is applied to each independent channel. Then the recording manifold is placed over the Q-plate. This manifold provides pressure control pathways and acts as a Faraday cage to minimize noise. Extracellular solution is added to each inlet well. Both saline solutions traverse through their respective and independent microfluidic pathways, and electrode resistances of about 2 megaohms are measured on all 48 channels. Meanwhile, the onboard cell preparation station keeps the cells in suspension. This feature provides at least 4 hours of unattended operation. Aliquots of cell solutions are pipetted into the onboard centrifuge and the cells are spun down. Following removal of the supernatant, the cells are then resuspended in extracellular solution before addition to each of the 48 channels on the Q-plate. The cells are applied to each inlet well and drawn into microfluidic tunnels, where a single cell is pulled into the patch clamp hole by suction, and the planar patch clamp process begins. First, a gigaseal is achieved. Because of the gigaseal, the recording quality is similar to conventional patch clamp. Additional suction from the pressure controllers ruptures the membrane for whole cell access. From this point on, baseline recordings of ion channel currents are measured and test compounds are applied through the inlet wells. During the course of an experiment, multiple compound additions can occur with each cell because of the continuous recording capability of the QPatch. In this experiment, many different compounds are being applied to each cell for higher throughput screening. A big advantage of the Q-plate is the glass surface of the extracellular solution tunnels. Test compounds are less likely to stick to glass surfaces compared to plastic surfaces, and this leads to more accurate dose-response experimental results. Zooming into the level of the ion channel proteins in the plasma membrane shows how the test compounds can bind to the channels and inhibit the flow of ions. Once the experiment is complete, the QPatch assay software quickly helps you go from raw data to current versus time plots to dose-response curves, complete with EC50 values. The QPatch: quality, quantity, and quick.